Now we are going to be doing scientific notations for time. So in this lesson we'll be doing really large time in years and also very small numbers, so really fast, quick times. So let's get started. Here we have 38 million years. So how would we express that in an expanded form? So it is simply 38, and then we have 6 zeros after it. Now, because it's a large number, we would want to express that in scientific notation. So we would start, remember we've got a decimal point here, and we want to end it up here. So 1, 2, 3, 4, 5, 6, 7. So it's moved 7 spots. So we would write this as 3.8 multiplied by 10 because it's a decimal place to the 10th, and it's 7 years. Okay, so let's do another one just so you know. Change the colour. Let's say 400 million years. So that would be written as such. Okay. Now we want a scientific notation. Remember, we want this to turn up to here. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's written as 4 or actually just 4 because it's a whole number, multiplied by 10. And remember, we moved it 8 places. So that's for large numbers. Okay, so now we're going to be dealing with small numbers. Shortly I'll show you what the units of time are for smaller numbers, but at this moment we're going to talk about nanoseconds. So in this case we've got 417 nanoseconds, and we want to express this with a scientific notation. So you won't know this just yet, but I will go through it soon, but just take my word that this is what, if we were doing it as an expanded form, 1, 2, 3, 4, 5, 6, yes, 7, 1, 7, 4, 1, 7. Even I had trouble counting how many zeros. That's how unnecessarily confusing large or very long numbers look like. Okay, so that's expressed as seconds. But we want to put it in an expanded form, in a scientific notation. So in this case, we want to move this decimal point to here. So we have 1, 2, 3, 4, 5, 6, 7. So we moved it 7 spots. So this would be written as 4.17 multiplied by 10 to the negative 7. Okay, and this is seconds. Now remember, it's negative here because this number here is less than 1. All right, let's have another practice. So let's say we did 15 nanoseconds. Ooh. So in seconds and in expanded form, it would look like this. 1, 2, 3, 4, 5, 6, 7. Okay. We want to move this to here. 1, 2, 3, 4, 5, 6, 7, 8. So it would be written as 1.5 multiplied by 10 to the power of -8, and this would be in seconds. Okay, so now let's just have a quick, we'll draw up a bit of a table and we'll go through units of time, particularly for those little numbers. So a nanosecond. If we had one nanosecond equals 0. Well, that didn't look really great. 0.000000001. Okay, so this is to the billionth point. Now let's look at a microsecond. Let me fix that up. Microsecond. So 1 microsecond equals 0.000001. And this might look familiar because it is the millionth. Okay, let's continue on. We'll have a look at millisecond. Oh, I keep stuffing that up. Millisecond. Okay, and it is 1 millisecond is 0.001, and you guessed it, that is the thousandth. We have centisecond. Okay, and that is expressed 1 equals 0.01. If you're watching the Olympics or any kind of race like that, you'll often see time expressed to this point. Okay, and that is to the 100th. Okay, and last but not least, second, which I'm sure you all realise is pretty easy. 1 equals 1. Well, 1. Okay, and that is to the second form. Okay, excellent.